The web has always been a place for unrestrained creativity and individuality. Conceived as a linked information system in 1989, it is now a staple of our lives. Video games were developing in parallel, and they're in fact an older medium that surpassed movies as an entertainment product in terms of revenue. With their stories and mechanics, some became part of the zeitgeist. But what if we could bring the experience of playing into the utility of the web? Hello, it's Ricardo. I've been working as a software developer for 5 years, and I'm self-taught. I made sites like trainingmode.pro, paperchat.net, and my own 3D portfolio. Today we'll be making an endless runner bird game in TypeScript using Blender and Three.js that I call Burton Boots. There are people out there that will show you how to render a cube on screen and charge you for it, but here we'll be making a complete product, from start to finish, including the conception of the idea. The project will consist of 3 main sections: concept art, asset modeling, and programming. You don't need any 3D modeling experience and only very basic coding concepts like variables and loops, as I'll be explaining everything from scratch. I made 2 open source repos on GitHub for this app. The tutorial repo where you can check out into any of the 45 commits that correspond with the episodes we'll be following in the programming part. And the original project repo where you can find the latest changes and media queries. I recommend you stick with the tutorial repo first or your own local one as we build the game together, and then check out the original repo at the end. You'll also find the assets in those repos, so you can skip the 3D modeling section if you're not so interested in that, but I would advise against it. Let's get to it. Everything starts in paper. The first thing I had to do was deciding on the shape, cause the bird is depicted as this very rounded thing most of the time, but I wasn't buying it. I wanted to stretch it a little bit more. Besides that, you got the eyes and the wings as the most prominent aspects of this design. And the thing with the eyes is that it might look like it has only one eye depending on the perspective, so a cyclops bird. But I quickly determined that looks terrible, so it's gonna have 2 eyes. And the wings can flow into the body, or they can be more of like a separate entity. So I was playing around with those possibilities from different angles to see what works best and what doesn't. And that crown is because I thought it would be interesting to see a sort of fallen king ghost bird, which is very much like a Dark Souls thing that didn't end up making it to the final game. But we got a regular ghost as his king, and that's cool enough. At this point I had decided that the bird will have a breast shape and sonic eyes, connected eyes, breast shape for the win. So I took the best designs from this page into the next layer and started adding more details to them, like getting a front view and a top view so I could, decide how the beak and the eyes would be animated. Is the beak going to be a single piece, one piece, or 2 pieces that can be animated independently? Of course, the latter is better. I ended up going for that. And the eyes, the irises can become smaller if the bird is startled, like, oh, I got scared. Or they can be larger normally, or they can change their shape a little bit if it's angry, that sort of thing. In the top view I was emphasizing that it has to be like a loaf of bread, but also a bird, so I gave it a little tail. It's not a pillow, it's just a squishy bird, so why not giving it more bird-like features, right? Taking notes on the expressions, the thing I mentioned about the irises shrinking or changing shape when the bird is angry, scared, or annoyed. And I was also playing around with that very simplistic shape of the wings. I even 3D modeled a version of the bird with those wings in Blender, but it didn't end up making it to the final game because I want people to be able to tell apart a few blocks of content or color when they have a quick peek at the game, and those wings were the same color as the body. So I ended up swapping them for the white wings we all know. There I also added the belly spot. That's gonna come in handy to have some color variety when we make some skins. And of course, make it more like a square or a ball rather than a rectangle. It's essentially a rounded rectangle. I detailed the wing flap animation as having a certain degree of bounciness and being something like up and down. And of course I had a lot of fun drawing the hurt expression for the bird. I wanted it to be something kinda funny that when it collides with a pipe or with the ground, you can tell that it gets really squished. I also considered having the bird come out of a pipe when starting the game, but I forgot about that, to be honest. Would be a nice thing to have in a pure iteration though. And then I gave it boots. Why not boots? Those are rain boots originally, but then they became traditional boots and regular shoes for the skins. What started as a fleeting idea became the staple of our character, and it's now what differentiates it from other birds. At this point, you would usually get inspiration for things like the level or the scenery. So I looked at the background and saw those buildings and I thought, oh, so it takes place in a city. And what's the most quintessential city you think of when you think of big cities? For me, it's New York City, so I decided the game was gonna take place there, and you will have the most emblematic buildings in the background, the skyscrapers. Here's my New York City skyscraper tier list, by the way, out of the ones we use in the game, of course. In this section, we'll be using the free 3D modeling software Blender to model assets for our game. The goal is to end up with two GLB files, the bird and the level where it takes place. We'll make a total of 9 models. I'll explain the Statue of Liberty and the Chrysler Building in detail, and the rest will be more abridged. Let's get started. The first time you open Blender, you'll see something like this. There's a lot going on, but don't let it intimidate you. We'll go bit by bit. In the bottom left corner of the screen, you'll see every key press and every mouse click I do, so watch for those yellow keys popping up. Click outside to close the start menu and select this camera, then press X to delete it. First thing we're going to do is save our startup file the way we like it. So you can see that the interface is composed of these panels or areas that show different things. You can merge them by clicking and holding the corner between two areas and dragging towards the area you want to delete. So if I drag this one down, it's gonna eat that little area that was in the bottom. Now if you drag inwards, you'll create a new area, either vertically or horizontally. This can be confusing at first, so just take your time to arrange your panels the way you like them. I can recommend having these 3 for modeling that will change later on when we have to work on a texture. It'll allow you to have 3 different perspectives of your object as it changes in real time. Notice how the panels are independent from each other, like you can scroll the options and change the camera angles without affecting the others. The interface feels a little bit jammed right now because I'm recording this part on a laptop for that fresh Blender install, but we will switch to a larger screen when we actually start modeling, so don't worry about it. When you're done with your panel's arrangement, go to File, Defaults, Save Startup File. If you wanna see it in action, just close Blender and open it again. You'll see that the interface is just the way we saved it. One more thing before we get going. Adjust your Blender preferences so we have the same ones going forward. Go into Edit, Preferences. Nothing to change in interface or viewport. In fact, jump to extensions and let's install some that'll improve our experience in Blender. Those will be Extra Mesh Objects, F2, and Loop Tools. You can read about each one if you want to dive deep. Now go to Input and check Default to Advanced Numeric Input. You may also want to check Emulate Numpad if your keyboard doesn't have a numpad because, well, the shortcuts from the numbers in the numpad are more useful than those from the numbers row. Lastly, in System, select the best option for your graphics card in Cycles Render Devices. You'll have to Google which one based on your GPU. If you don't have one, that's fine too as long as you're still able to run the program, because we're not going to be rendering things in Blender but rather exporting files out of it. Quick test. Press Tab and you should see all of these options. Those are the different modes Blender has. For now, just get used to switching between Object Mode and Edit Mode. All set with the config. Now let's get started and model some cool stuff. For the Chrysler Building, I'm only going to delete the default light and leave the cube alone. Let's add a reference image and lay it flat on the floor. This is a cool blueprint I found online. So to do that, just have to set all of its rotation values to 0. Open the item transform panel with N and set them to 0. Now we can look at it from top view. This will allow us, if we switch to X-ray mode, to position our cube on the drawings and adjust its shape to match perfectly. So let's do that. Go into edit mode, scale it and place it on top of the drawings. Now add loop cuts and pull and push those new vertices to match the blueprints. After you've done that, you'll see that the building consists of 2 main columns that go upwards into the heavens. Extrude them up and add another cube on top of them because the columns aren't just monoliths. It's like they spawn other columns inside and they go on becoming smaller. Now we're gonna do something crucial. Go into edit mode and add 2 edge loops to the main body's cube and delete a third of the object, so you're gonna be left with only a quarter. After that, add a mirror modifier and apply it to the X and Y axis. That will allow you to edit just your little corner and changes will be replicated in the entire cube. Yeah, we're pretty lucky that the Chrysler Building follows this pattern, cause it's gonna save a lot of work. Remember, this is an asset that's gonna be seen mostly in the background, and the building's gonna have some nice details, but not necessarily the gargoyles. I'll tweak it until it looks good from all angles. So I'll be going into right orthographic by pressing 3 and then switching into user perspective by pressing my mouse wheel and moving my mouse around. That way I can have a look from many perspectives. Now I'm gonna duplicate the gargoyle to save it as a backup and apply the modifiers to the main one. The backup is saved with the modifier in case we need to go back and edit it. Select your resulting gargoyle, then on backup one, press shift and click the main body of the building so that both of them are selected, but the main body of the building has to be the last object selected. Then press Ctrl J to join them and you'll see that now there are 4 gargoyles, one on each side. This is just a result of joining the objects together because the building has a mirror modifier in the X and Y axis. Now if you go into edit mode and duplicate the gargoyle to have 2 on each side, it will also be mirrored in real time, which is pretty cool. Once you have your stars ready, I'm going to actually carve them out of the top of the building by using another modifier. So select the top base front object and add a boolean modifier. What this does is that it's going to delete whatever geometry exists in the intersection between two objects in the shape of the selected object. So your settings must be different, and for the object select stars. Now if you hide the stars, you'll see that the top of the building has these carvings shaped like the stars we just used. How cool is that? Now that the measure for building is done, we're gonna texture it, and for that we're gonna need an image editing program where we can draw. Any will do. I'm gonna use Photoshop just because I'm comfortable with that one. You can start by adding a 512 by 512 canvas that we're going to work on in just a minute. But first, let's set up our Blender interface for the workflow that's about to take place. Click and drag this little corner to create a new panel and set it to UV editor. This is where we're going to adjust how the texture looks in our model. And for this one down here, set it to shader editor. And this one can do a lot of stuff, but we're just going to use it to upload our texture files into Blender, really. Next thing you want to do is create a material on the main body of the building, and we have to ask ourselves, what do we want to show in this material? And that's of course our texture image. So go to the shader panel and Shift A to add a new node and search for image texture. We'll add our texture file in just a second when we save it in Photoshop or whatever program we're using. Of course, remember to connect the image texture node to the main node of your material, or you'll see a black object. For the first iteration of our texture, I'm just gonna go with a plain background and a few rows of rectangles that are gonna have smaller rectangles inside of them. That are gonna be the windows. These textures are gonna be kept very simple so that they are as lightweight as possible in terms of file size. We're gonna be doing the legwork of making them make sense in Blender. Now add the texture file, which is going to be a PNG image, into the texture node and switch into material preview mode by pressing C. And you'll see that the main body of the building has a texture now, but it's all over the place, makes no sense, and we're gonna fix that in just a moment. But first, make sure to add the same material to all other objects that compose the building. So I'm gonna go ahead and add it to base, base 2, base 3, top base front, and spire. And I'll add a couple more edge loops to it so that I can have these sort of stripes where I can add columns of windows. It's like telling your mesh, take this face and show only this part of the texture in it, as if it were a sticker, and that is the concept of seams and UV mapping. Just unwrapping your object is not going to be enough most of the time. We need our faces to be displayed in a specific way in order to align them with the texture in the UV editor. And that's where seams come in. Seams are ways to mark edges so that when we unwrap our object, those edges and the faces they form will be displayed together as an individual piece that we can then move around and place anywhere we want in our texture. In edge selection mode, select all of the edges you'd like to mark, right-click and select Mark Seam. This option is not going to be available for face selection mode or vertex selection mode, so careful with that. However, you can select faces in face selection mode or vertices in vertex selection mode and then go to edge selection mode and mark seam for all of those selected edges. Once you have your seams ready, select all of your objects and unwrap it again, and you'll see that the result is different this time. Feel free to repeat this process as many times as you deem necessary. UV unwrapping may seem intimidating at first, but you get better with time and practice, as with most things in life. And now I've got these really nice rectangles that I can place on top of the windows in the texture. And we're gonna do this for the rest of the building basically. For the triangles that are in the layers of the top of the building, I'm going to add a new material that's going to be yellow and it's going to have some values in emission. Emission is a property that allows materials to emit some light instead of just reflecting it, so it's like it's gonna glow. You can see this by switching from Material Preview mode into Render by pressing C. So you'll see that the building has its texture, but it's all dark except for the triangles. That's because we have no light in the scene right now. Now we can switch back into Material Preview mode because that one applies a plain lightning to the entire texture, and it's just more comfortable to work that way. One last detail. You might have noticed that our image looks a little bit blurry, and that's because of this setting of the image texture node called interpolation. It controls how Blender reads the texture, especially when seen from afar or when stretched, as we've done with some of our UVs. For example, if you take a piece of your UVs and scale it down, you'll be forcing to show a smaller part of the texture in a larger area of your object, and therefore causing some blurriness. In its current value, linear will smoothen the pixels into a sort of gradient. Now change it to closest to have sharp edges and a pixel crisp result. That's because closest, as its name indicates, picks the nearest pixel's color in the area and runs with it. It works best for low resolution, pixel artish textures like these. For the rest of the buildings, we're going to be using the same techniques we learned here, so I'm not going to be as explicit or detailed as I was with this one because, well, otherwise this would take forever. If I had to simplify the main game scene, it would be a series of platforms having pipes on top and bottom that repeat endlessly with small differences in height to create the game loop. So I'm just gonna create a pipe and duplicate it here and there to visualize how everything's gonna look. The background will have the main buildings and generic ones, so let's model those right now. We'll just scale them in different ways to have some variety, but the base design remains the same. There will also be a bush between the buildings and the foreground, and we're going to make it using metaballs. Blender objects are attached to each other, creating different shapes, and we can turn them into a conventional mesh once we're done. This will usually result in a crazy amount of vertices, something like 200,000, but we'll reduce it with a modifier in just a moment. By the way, metaballs only attach into each other if they share the same base name, so be careful with that. It's what we refer to as a metaball family, and by base name I mean that it's okay if they have a dot and a number at the end, which is the normal behavior when you duplicate them. Now let's import our main buildings into the scene. We want them in one piece, so for each one of them, select all of the objects that compose them with A, then duplicate with Shift and D and apply all modifiers in the clone meshes before joining them with Ctrl J. Copy and paste the result of each building into the main scene. Literally just open two Blender windows and do Ctrl C and Ctrl B from one to another. Back to the metaballs. Apply the decimate modifier with a ratio value of something like 0.02 to reduce vertex count. And we won't even lose much of the smoothness of the original shape. With all of the special buildings in the scene, align them together and scale them to match their heights in real life. texture time. And this one's gonna be pretty big to account for all of those objects, so I'm gonna go with 2048 by 2048 pixels. And I'm gonna start by adding a reference picture to pick some colors from. Getting the pipes right is extremely important, so I'm gonna try many things here, starting with a combination of solid colors. But that didn't work. So actually the best thing here is to create a gradient and apply it to both sides of the pipe. That will also mimic a light reflection. The ground texture is one of my favorite parts. We want it to look as tasty as possible, just like a cake with many layers. I'll start with a base yellow background and then add a few layers separated by perfectly looping stripes. When it comes to the UVs, both sides don't need to match perfectly because the players will never see them connect directly. Now we're ready to move on to our main character and last model, the bird. First things first, we want a reference picture in the scene, a web bird and our own concept art. I'm also gonna copy and paste a pair of pipes from the New York scene just to have a better idea of how the bird would look with them. I'm gonna start with a round cube and quite literally use the concept art as a reference to get the best possible shape from every angle. I'm also going to add a few plain colors through materials to have a quick conceptualization of the final result, but we're going to paint a texture later on. I consider this simpler version of the wings where they're yellow just like the rest of the body, but It didn't allow for much expression and it all looked too uniform. So I'm gonna make a separate mesh for the wings with a combination of stretched round cubes that we will then merge together in edit mode. Also, yes, I experimented with adding eyebrows to it, but wasn't convinced with the result, so they ended up being discarded. The texture will have no difficulty whatsoever, just a solid color background, some squares, and an oval for the belly area. You can make different textures this way to create skins for your bird. The bird still needs to be animated. We need actions such as falling and flapping, but I'm leaving that for some other time because otherwise the video will get way too long. Suppose you've got your model ready and want to export it. Well, just go to File, Export, GLTF, which is the format we'll be using for the web. First of all, set the format to GLTF binary. This will output a single .glb file instead of an entire folder with all the texture used in the model, which is what GLTF separate does. It's very convenient having everything in one place. As for the export settings, one of the most important ones is objects to include. Don't let this trip you up. If you check include only selected objects, you'll get nothing if you didn't select anything before opening the export menu, as obvious as it sounds. I usually leave it with just visible objects checked so that way we don't export our hidden backups. Another relevant setting is transform way up, because Blender uses the Z-axis for up and down, but many other 3D engines use it for depth, and Three.js is one of them, so make sure that's always checked. You wanna apply the modifiers and also export the UVs and normals, otherwise textures won't show up. I also applied compression to the maximum because it reduces file size a little bit and I've never noticed a difference in quality. That's mostly it. Now just hit export and you're done. There are many websites where you can preview your GLTF. Before we start with the programming part, I think I should be dressed appropriately. Let's go. With our Bird and New York scene GLB files in an empty directory, we're ready to start working on our game. But first, let me show you my Node and npm versions. There you have it. So let's keep it simple and create a React app with Beat. Pick React with the TypeScript and SWC variant and start the server now. Let's edit the boilerplate a little. Start by setting the server port to 3000. Now install the npm packages we'll need, which won't be a lot. Start with Sas Embedded as a developer dependency, and then React Fiber, Tray, and Jotai, which will be our state management library. Also, create a prettier file to format the code. You'll need the prettier VS Code extension for it to work. Make sure the file name has 2 R's at the end because I made a typo here that'll be fixed later, but it won't work with just 1 R. And move the models to the public folder. I made a few textures that I'll move to the public folder. You can make yours following the pattern I show you while making the bird model. Let's create the main folders of our application. There'll be components, UI with an InteractUI.tsx component. Outside of the UI folder, create Bird and NewYork.tsx, all of them empty for now. Create the styles folder and make a globals file with some default styles for root, HTML, and body. After that, delete the CSS files that the boilerplate included and add your own variables file. You'll have to remove the references to the old files as well. Back to our bit config. I'm going to add an option that prepends an import of our variables file to all the CSS files, just as a convenience thing so that we can use our SCSS variables anywhere without having to import the file every time. Now leave just a div with hi in App.tsx and import our global styles file in main.tsx. After your verify tag compiles, import the canvas component from React Fiber and place it in app with these basic settings for camera. Create a store folder and file. Here we'll add our first global state variable with the showTie library. It basically creates store variables that we can get and set in any component. No need for complex reducer logic like in Redux. That takes us to creating a debug folder and debug.UI.tsx component, because the first thing we'll need is a small control panel where we can tweak things like camera positioning and the sort. I'll start with a stats component and OrbitControls that will let us move the camera in our scene by clicking around. Add the component to App.tsx and you should see this little FPS panel show up. We can then control if we render it or not with our state variable. Now on to New York. Let's render our scene by loading it with the useGLTF hook by Trey. We just want to see our model on screen, but I also added a scene_children state variable which will be an array of the specific objects we want this component to render. It's very practical. Create a types file and add scene_child to it, which will consist of a 3D object rendered as an element and the corresponding object of its data. And move the stats panel to the bottom with CSS because it has no prop for that. Add New York to App.tsx and there you go. We can see our model. Nice. Now click and hold to move the camera around, right click and hold to pan, and use the mouse wheel to zoom. Have some fun, check the details of the model up close, read the logs, and verify the object names are the same we assigned in Blender. Alright, we need a control panel to quickly adjust the main variables of the game, so I'll install LilUI for that. There's a few other packages for this purpose like Leva, but I just find LilUI to be pretty reliable. We're gonna use it in debug.UI.tsx, so I'll create an instance in the store and import it across the app. Add a useEffect with the camera and UI as dependencies. Inside, I'll create a folder for the camera position, zoom, and rotation properties. Of course, we want no duplicate folder, so we'll destroy it in the cleanup function. Now check it out, we can control our camera from the LilUI panel. So let's do the same with the directional light in NewYork.tsx. We'll store its position in a state variable and add a LilUI folder to control it. You can also use a ref for this. Doesn't matter much since we're not setting a new value for it, but only controlling its properties. And now we can control the directional light from our panel as well. We want our game to be a 2.5D experience, so we'll use the orthographic camera because it doesn't render depth. Objects further away from the camera look the same size. The default camera being used here is the perspective camera, so let's delete that and add our own. By the way, notice I'm using a near value of -100. This can be swapped for a larger value in position C, because right now the camera is pretty much at the center of the scene, but with the ability to look from far behind. The camera is now looking at the scene from a straight angle, and it doesn't play very well with our orbit controls, but we're able to control it perfectly if we comment them out. We can rotate the camera from the panel while OrbitControls is active because it uses a property called target to determine where the camera is looking at. But we can also add a folder for that in LilUI, just as a curiosity. To do that, get a reference to the controls, and use it in the debug UI useEffect with an if statement to add it only when the controls exist. However, I'm leaving the orbit controls commented out because we're gonna work with the orthographic camera for the rest of the project. I'm gonna adjust the zoom and camera position so that we can get a clear view of the platforms from a certain distance. Not too far away, but not close either. These settings will change through the project depending on what feature we're working on. It's time to introduce the concept of a slice because our game will kinda revolve around it. So let's define a type for it. A slice consists of a terrain platform and 4 pipes. Initially, I wanted the slices to have only one pair of pipes, but that would have implied reducing the terrain size and therefore the texture, and I didn't want to edit the texture again. Back to NewYork.tsx, the scene will be rendered by a specific function instead of simply dumping the entire model onto it. Alright, now we're gonna add a useEffect that will be in charge of setting up the first slice. That is, grabbing the one pipe and cloning it on top and then adding the pair that follows. We can turn off this ESLint rule, by the way. Also, my prior config wasn't working because the file name had a missing R. Now it does format correctly on save. As for the useEffect logic, I'm just gonna find the object called pipe_0, duplicate it, and adjust its position and rotation. The distance between pipes was obtained through trial and error. More or less just go with what feels right. You can always play around with these values to visualize everything. I'm setting my print width to 80 in Printer because I'm using half a screen and need all my code to be visible without horizontal scroll, but you can use whatever value you prefer. I'm gonna place debug UI on top of the New York component because that will determine the order of the little UI folders. Back in New York, I've added some values to a constant like distance between pipes so that we can organize them in one place. This is in preparation for our next method, addPlatform. First, let's see it in action and then we'll go over it line by line. I just click this button right here and another platform is added to the game. Pretty cool. So the function takes a numeric argument for the amount of platforms we want and does something very similar to the setup. Just duplicates the previous terrain with its pipes, offsets them, and returns the result. In the pipes loop, I'm using the modulo operator to determine when to jump to the next pair of pipes. So the pipe with index 1 will be the top one, which will go inside the if statement because 1 divided by 2 is 0.5, not 0. That's what the modulo operator does, returns the remainder from the division of two operands. At that point, we increase the pipe's number and reassign last pipe, because we take the position of that last pipe as the initial position of our clone, and then we add the distance between pipes constant. As always, adding logs helps a lot to visualize the entire flow. Notice how the current pipe's number grows with the index. So remember to add this function to Lil UI, though we'll add it to the game loop in just a few minutes. There's another important concept for the game, and that is bounding boxes. Let's add some type definitions for that. A bounding box, called a box tree by Three.js, is an object with min and max properties, each one a vector tree that creates a box of coordinates that encloses an object. We can use them to check if our bird has hit a pipe or passed between them. So I'm going to use an object that will contain other objects with bounding boxes classified as collision or sensor. This object is going to be called the boundingBoxesMap. Let's add it to our store. Back in NewYork.tsx, import it here because we're going to start adding things to it when setting up the first slice. So let me tweak some details here and there, and then we'll go into the meat and potatoes of our bounding box logic. The addPlatform method will return an updated boundingBoxes map, because of course everything that deals with moving or adding objects into the scene has to update their bounding box. And I'm going to add the same logic here. Don't worry, we'll move it into its own function in just a second. If I call addPlatform inside our GUI useEffect, React will complain that we need to move the method inside useEffect because it makes its dependencies change on every render, since methods are recreated on every render. Or we can wrap it in useCallback, so we're gonna do that. UseCallback recreates a method only when its dependencies have changed, and it's a standard React pattern. You can use the quick fix message of VS Code to add the necessary dependencies, which are the state variables used inside. Check that it still works. Yeah, it does. Now onto the main dish. The bounding box logic consists of a simple loop that goes over every object and saves its bounding box with the collision type. We'll add sensors later. There's also a box helper that we can add to the scene to really check our boxes are where they should be. Very important. Try adding more platforms and moving the camera to see your boxes in there. Nice. So quick recap. We created new types for the bounding boxes map, added it to the store, and imported it in NewYork.tsx and added logic to populate it in setup first slice and add platform. I'll be scrolling the entire file so you can see all changes in case you missed something. Let's take our bbox logic into its own method. Right now it's in these two places. Method's gonna be called addBboxes and will take an array of objects over which we'll iterate, starting with collisions only. Apply it where we had the previous logic and verify everything still works. We're gonna need sensors between pipes to detect when the bird passed between them and scored points. So let's do that now. I'm just gonna detect the bounding box objects with the word pipe in their name and loop them in pairs. Then construct a bbox with min and max using the bottom and top pipes. You'll see it on screen in a moment. The helper color for these boxes is gonna be crimson. I'm subtracting 1 from the entire box to make it slightly smaller. I consider that the bird has scored a point when it passed through the middle of the pipes, not just when it reached the outer edge. Yeah, that looks pretty good. It's time to add another core gameplay function, and that is movePlatformToFront. As the platforms move like a thread mill, the ones that we've passed and are far beyond the scope of the camera must disappear and reappear at the front. Let's go over that logic. I'm gonna set the X position of the platform we want to move to the position of the last platform plus the size of that platform. So it's literally move to the end, then move one terrain away. Platform slices must be updated to reflect the real position of each slice. So remove the targeted platform and push it to the array. We also have to update the bounding boxes. Let's add it to UI and test it out. First, we add a few platforms, and now we move the last one to the front. Oh, the helpers are not being cleared out. Let's do that in addBboxes. Check if it exists first and remove it from the scene in that case. And now that works. But as we move more platforms, the pipes start getting left behind due to an incorrect offset. We'll fix that in a few minutes. Let me delete this setup first slide function real quick since we don't really need the named function inside the useEffect. It was for clarity purposes only. Now that we have all individual pieces for our game loop, let's actually make things move. Go to useFrame, a React refiber function that executes the code we pass inside before rendering every frame. In vanilla.js, we would use window.requestAnimationFrame, a method that tells the browser we want to perform an animation before the next repaint, which usually happens at the display refresh rate, most commonly 60 frames per second. So I added a couple functions that we'll need in useFrame, updateBoxes and updateSensors, because we'll just move each platform and its pipes inside useFrame and move the last ones to the front after a certain threshold. We need to keep their bounding boxes updated. Take a look, the platforms are moving now. That parameter we get in the useFrame callback, delta, is the number of seconds that passed since the last frame. So if you divide 1 by delta, you get the current FPS in that moment. For example, mine is around 0.006, so I'll have around 166 FPS. Of course, it varies a little bit, so you'll have to get an average over time. We have to multiply by delta the values we use for animations inside useFrame to guarantee a consistent animation in each frame. Otherwise, they'll run faster on screens with a high refresh rate. And here I'm just commenting the platform and pipes movement so you can see that they're indeed moving from the useFrame code. Now that the platforms are moving, we can add all of them on init, and that means a new useEffect. With a run when the number of slices is 1, so right after we set up the first slice, adding the remaining platforms. That's why I'm using Torah platforms -1, because we just added the first one. And there you go. Now count the slices and you'll see that the total 7 platforms we set are here. The ROM pipe subset is biting us here again though. The last platform is empty, but there's just one commit left before we fix that. Maybe you noticed though that the sensors are big as if we're not offsetting them. That's because we forgot to do it in updateSensors, and since it runs on every frame, it overrides the initial sensor set when the platforms were added. Let's do it there as well. Let's call movePlatformToFront in NewYork.tsx useFrame. But first, I'll set a safe delta. That is, the maximum number I'm willing to use as a delta. That's because when we switch tabs, delta briefly shoots up to values like 1.5 seconds for a couple frames or so, and that'll mess up your animations. I'll use 0. 0.1. Smaller values like 0.01 will make animations look overly floaty and slow in less powerful devices. If you just develop on a machine with a decent graphics card, these details will be easy to miss. Depends on the application though, 0. 0.1 might be too much for some, so always test it out. By the way, I also adjusted distance between pipes, so now they won't be offset as they move to the front. I got that value just experimenting, but I'm sure there's a clever or fancy way to do it. So I'll invoke movePlatformToFront at the end of useFrame if the terrain of the given platform has crossed a certain X threshold, which I also determined by trial and error pretty much. Let's zoom out and see it in action. Now faster, and faster. Now that NewYork.tsx is mostly done, let's get to work on the Bird component. I'll add a store variable for playing and the initial Bird.tsx boilerplate, which is basically loading the model in useEffect, setting a bbox and the scene child that will render, and that is the bird rig, parent of the bird mesh. We need to store a bird body as the object will use the bbox of to check for collisions. I'm also using the useAnimations hook from Dre to play the idle animation of the bird. We'll get to play all other animations in just a moment. However, notice that if we use the bird rig as the bird body, the bbox is just a bit too large. So I'll export the cube with the bird model to use it as its bounding box. It's the easiest solution instead of trying to trim the bbox on every frame. Take a look at the bird model. The cube is slightly smaller. All we have to do is use it as the bird body, but don't return it. Just copy its position into the scene child on every frame so the bird rig follows this invisible cube. We'll need a method to manage animations in our bird, but first, let's define an object indicating the speed that every animation should run at. You may have noticed that the idle animation runs just a bit too slow, so this addresses that. Most animations will run at 1, but the idle one will use 1.5. Just set the timescale property of the given action. That determines how fast it runs. Besides that, we also want the bird to glide up and down in the home screen right before starting the game, so I'll add a couple of constants for that and some logic in useFrame to constantly add and subtract from its Y position so it stays in that range. There's a better way to do this, I just wanted to show you the manual way first. Now take a look at that, the bird slowly flying up and down. Let's install the gsap library. It'll help us animate certain movements and transitions in a very straightforward way. We won't rely on it too much though, don't worry. Import it in Bird.tsx and add another useEffect that runs after the bird body has been set, without any dependencies for now, but it'll have them soon. Use gsap there to move the Y property until it reaches the gliding animation top constant, with sign.inout as the easing function or whichever you prefer, and the other options you see here. You can delete the custom gliding logic in useFrame now. Here's a quick recap of the gsap integration. It's time to add a couple more store variables to the game, one to keep track of the score and another one to know when the game just ended. So let's start preparing the logic for what actually happens while we're playing. For that, add a new button in NewYork.tsx UI where you set the store variable playing to true. To do that, just add another function to the platform functions object in the LilUI useEffect. Now back to Bird.tsx. Start by adding a jump velocity ref. This is the one we're gonna add into the bird's Y position to make it go up when jumping. Also add game just ended and playing as dependencies of the gliding useEffect. Next up, write an if statement that runs only when playing is truthy. It will apply gravity to the bird body and check for collisions using our bounding box map. We can simply use the InteractUI.box method of bounding boxes to check if two boxes intersect. We consider that the player has scored a point if the box is of type sensor, and the game ends if it's of type collision. The value of jump velocity also has to be reduced or decimated on every frame. Try it now. The bird starts falling immediately and stops when colliding with a pipe. Perfect! Alright, I'll wrap the start playing LilUI function in a timeout of 400 milliseconds so testing is easier. In order to be able to jump, we'll need keyboard event listeners to detect when space is pressed. Let's add another useEffect for that. If we jump, the bird goes up indefinitely. That's because we're not decimating the jump power hard enough. The variable should be jump decimate power, not frame gravity. Much better. It's almost funny seeing the bird go up and down without the flap animation. Let's try as if we're actually playing. Very nice. Recap time. In this commit, we added the keyboard event listener for flapping, correctly decimated jump power, and also saw what happens if we don't, that the bird goes up forever. As the bird falls, it should rotate forward as if it's on a free fall, and then go back straight up when it flaps. Something like whoop, whoop, whoop. Yeah. To do that, I'll set a falling bird rotation limit of -1.6. Create a rotation twin in a ref that will be used in useFrame and also adjust flap timeout, because we want the rotation to start a few milliseconds after we last jumped. But first, let's create the wing flap method since we'll need to isolate that logic to jump and click. Wing flap will additionally set the bird's C rotation property to 0.5 so it's looking upwards right after flapping. Here we'll also post the rotation twin that will activate inside useFrame in just a second and reset the flap timeout. Now we can edit the keyboard useEffect to add a mouse down listener as well. Try it again real quick. Alright. We're ready to introduce the Bird rotation logic in useFrame right after applying gravity to it. What we want here is to check if the rotation C has crossed a certain threshold, and if the JustFlap timeout has expired. Then we execute a gsap function to rotate the scene child. Look at that, it's falling headfirst. And of course, it stops when we collide with something. After the rotation twin is created, we just need to restart it, because it gets paused in the winFlap method. Also, in case you have any trouble assigning the Node.js.timeout type to the JustFlap timeout, include Node in the types array of your TS config. You can also type it as the return type of setTimeout, but I prefer it this way. And as always, here's a quick recap of the changes. It's animation time. Let's create a changeAction method for animation management. It will receive an animation name and optionally a parameter to decide if it should play only once, and another one for the fade duration. The function simply checks if the requested animation is the same as the one we're currently playing. That's why we keep track of current action. In that case, we reset it if possible, because the following animation doesn't need to be reset. In case of a new animation, we get it, assign the loop and timescale values, that is how fast it runs, and then proceed to fade out all running animations before playing the new one. That's because when we collide with a pipe as the bird is falling and we press the jump button, the falling and winFlap animations might still be running when we request to play the bird hurt one. Let's call our method in winFlap. Wow, that looks so much more dynamic already. Now the animation for bird falling. That must happen while it rotates forward with a threshold of its own, because it's like it gets scared that it's in free fall after a certain point, not immediately when it stops flapping. And finally the animation for bird hurt. Here you can adjust the third parameter, the fade duration, to get either a very quick, practically instant transformation into the host state, or you can prolong it a bit more with a value like 0.5 to see how the bird gets squished. Let's recap the commit. There's this new type called bird animation name, which simply holds all the strings for the bird animations, and then our entire changeAction method and its invocations. Take your time to play around with it. It's time to create an actual user interface on the page so users can start the game and navigate around. First, grab the fonts we'll be using and move them into a folder called Fonts in the public directory. The fonts are free to use and their license can be found online. Now go into the InteractUI component and add the following boilerplate. Just a function to render the menu with some dips and a start message. It won't compile because the styles don't exist yet, so create an InteractUI.module.scss file inside styles components. We'll go over them in a second. I'll just add the initial styles and sass variables to variables.scss, where I also define the font families, making them available to our app by including a mixin. Let's hide the helpers to see our menu real quick. Now take a look at the whole structure. It's pretty simple. Add these rules to move the Lead UI interface to the left side of the screen so we can work on the menu with the dev helpers on. So about the styles, InteractUI will contain the whole screen with a fixed position on width and height of 100%, and it divides the screen in a 6x6 grid. There we have the right area with the menu and the game title, crafted by using a text shadow with 5 values. Tweak each shadow individually to see how it comes together. This at include is the way we use mixins in Sass, the ones we defined in variables.scss. I like using mixins for font family because it's very practical and reusable. See how it doesn't work if I comment out the font face declaration that imports our font file. I'm gonna create a small button component to isolate all of that structure and styles. This does make InteractUI feel much lighter, as it should be. Define new color variables and go use them in button.module.scss. It'll include a div for the background, another one for the content, and hover and active states. Make sure to remove the previous button styles from InteractUI.module.scss. The gist of the matter is that I'm creating a double border effect by using a background dip. Simple but effective. The start message must remain in the bottom center of the screen and have a blinking animation. So let's add the keyframes for that in variables.scss. Test that the text doesn't wrap in smaller screen dimensions. We'll assign it to columns 1 to 4 for that. And don't forget to wire up the props of the button component. With the minimal UI setup, let's get back to some game logic. As soon as we start playing, we want all the pipes to move up and then down, rearranging their position to serve as obstacles. As always, it all starts with a type. Define pipe state as idle, opening, rearranging, and playing. Platform slice will now receive an optional array called pipe Y targets. This is where we'll store the Y positions that each pipe will target in useFrame while they're being rearranged. You should also include a new store variable that'll help us identify the last pipe the bird just passed, and another one for our current pipe state. We're ready to go to Bird.tsx and import these two store variables. First thing I'm gonna do is set playing to true in wing flap, so that the game starts by just pressing the enter key or clicking. Now onto the main changes related to our new variables. Move the collision logic up here, outside of the playing if statement, because we'll need to know what was the last pair of pipes passed by the bird, playing or not. In the event listener's useEffect, make sure to check for the mouse event's target property and act only if it's the canvas. This way we avoid starting the game by clicking on the little UI panel. So the intersection block will be updated to set the last pass pipes using their sensor name and to score only 1 point per pass pipe. The goal is to make sure we are not adding points indefinitely as long as the bird is within their sensor. Besides that, I modified the collision if statement to execute when the object being hit is a platform floor. Also yes, the bird goes swinging up and down when we collide. We'll fix that very soon. Go to NewYork.tsx and import the store variables playing last pass pipes and pipe state. Add a constant called pipesYoffset2, which will be just 20 and represents how much the pipes will go up before rearranging into their final game-ready position. The first thing will be to trigger the pipes opening when playing becomes true, and for that a useEffect will come in handy. Here we'll find the last platform passed in platform slices, grab the one before, so the penultimate one, and add a pipes Y targets to it and all platforms before. Subtract the Y offset constant if they're bottom pipes and add it if they're top ones. You'll see it in action in just a second. This signals the pipes must start moving to meet their Y target now. Enter the rearrangePipe method. It will be the one in charge to check if every pipe has reached its Y position target and add or subtract to it to get there. It will also set the Y target of the next pipe when the current one is 75% close to its target. This is what causes a waterfall effect when opening the pipes, instead of opening all of them at the same time. This part also checks if the next pipe is the first one of the second pair in the platform, or the first one of the next platform to add the Y target to them. I'm using an offset instead of the exact target value to account for possible inaccuracies like lag or skipped frames in devices with lower performance. Finally, when the pipes reach their target, we assign them a target of 0, and when all Y targets in the platform are 0, we delete the array. Setting them to 0 is not a problem because we only perform that logic if the value of the Y target is truthy. The function will be called in useFrame, right after updating the bbox of a pipe. We will of course need a Y velocity to pass to it that will determine how fast they move towards the Y target. Let's try it. Yes, look at that, pretty satisfying. Now we only need to give them random positions for playing, but that'll be easy having the rearrangePipe method ready. Alright, recap. We allowed the wing flap method to start the game on click or space press. We are also now checking for collisions in Bird.tsx even if playing is not true, so we can keep track of the last pass pipes. Included store variables to keep track of the pipe state and the last pass pair of pipes. Of course, we added new types for the pipe state. And in NewYork.tsx, we trigger the pipes opening on game start by giving them Y targets, which cause the pipes to move up in useFrame with rearrangePipe. Okay, I added a useEffect just for testing purposes that will log pipe state every time it changes, because we're gonna make full use of it to implement this logic. Right now, the pipe state goes from idle to opening and stays there. In order to rearrange them, we need to save their initial position first so they can return to it when restarting the game after a game over. I'll create a ref for the base Y position of the bottom and top pipes and set it in the useEffect where we set up the first slice. You can see it logged here. Before we proceed, create a file to store a few helper functions and include one to get a random number in a range. Now create the addOffsetsToPlatform method, where we get two zero random numbers between 4 and 6. This is the distance we'll make each pair of pipes move up or down. Basically, we get the random numbers and also randomize if they should be negative or not. And if they're too close and both of them are either negative or positive, we switch one negative value. This is so that there's always a little variety in the pipe's height. Then we add the values to the platform's pipe Y targets where the pipes are apply offsets map allows, which is the second parameter of this function. Because we might want to offset only the first or the second pair of pipes. We'll call this function in movePlatformToFront, which is already called in useFrame. Now we only need to call it when starting the game, and that means it's useEffect time. Create a new useEffect that'll execute when we're playing. The pipes have all fulfilled their white targets and their state is rearranging, which translates to when they have just opened. Here we'll add plain offsets to all pipes after the one we just passed. The pipes before will stay up when the game starts. So, modify the game velocity to be 5 and let's test it out. And there you go. The pipes get correctly rearranged in random positions and will continue to do so as they move to the front. Notice how the logs show the flow of the pipe state, from idle to opening to rearranging to playing. Let's play a little bit. Very nice. Quick recap. In this commit, we added the helper functions.ts file, saved the initial Y position of the top and bottom pipes in NewYork.tsx, and added yet another important method, add offsets to platform, that allows us to give random heights to each pair of pipes. We call it the movePlatformToFront and in a new useEffect triggered when starting the game, after all pipes open. Our bird has been going a little crazy every time it collides with something. That's because the gliding animation is activating when it shouldn't, making it go up and down between the gliding animation top constant and the point where it collided. First of all, rename the game just ended Atom to Game Over, that was too verbose. Set it to true on collision. Now, prevent the gliding animation useEffect from running when Game Over is true. Let's see if it worked. Yup, that fixes it correctly. If I remove the check or bird swings again. Don't forget to add the same check to wing flap. Return in case of game over because we want to restart the game by pressing a button designed for that. You might have noticed that the burst lights up on collision, but only when crashing mid-flap. That's because the playing if statement must cover steps 4 and 5, so we only apply jump velocity to the bird while playing, and immediately stop when not. As you can see, in this commit we fixed two small bugs that were bothering us for a while by just swapping the existing store variables around. Shows that the game is mostly complete by now. Let's add a sprite when the bird collides. So an image with a set number of variations that show up one after the other very quickly to simulate a dynamic effect. I made this one in Photoshop. It's very basic, but it'll do the job. I also made a JSON file for it in accordance with the format requested by the sprite animator component of the React 3 library. Move both of them into the sprites folder inside public and define a showing impact state variable in Bird.tsx. Followed by a little method to conditionally render the sprite animator component is set variable is truthy. Pass the image and JSON location along with the remaining props. Check the library docs for more info on each one if you're curious. Now we can just return scene-child's element, where a fragment containing it and the invocation of getImpact sprite. Nothing's gonna happen yet though. We have to set showing impact to true when the bird collides in useFrame. Try it again. Perfect. The sprite disappears automatically after it plays because we're setting showing impact to false in the sprite animator on an event. Otherwise, it would stay there in its last frame. We're back to InteractUI because it's time to add a game over screen. First things first, create a wait helper function that returns a promise that resolves when a timeout completes. We'll use it to add and remove CSS classes for certain animations. After that, we'll need a couple of keyframe animations to translate X and Y. In InteractUI, create a couple of state variables, showing UI and UI exiting, and import the plain store variable. At this point, we can include a useEffect to animate the title screen when the game starts. Set UI exiting to true and wait for 900 milliseconds until setting it to false again, and then we can add CSS classes based on that. To do that, we'll isolate the most important pieces of the UI that need to be animated in their own functions, starting with the right area. Then we pass a class theme to it only if the UI is currently exiting. Now go over to the styles and add a rule for the elements you want to animate with the keyframes we just made. This will make the start message go down and the right area go to the right when starting the game. And it looks awesome. Quick recap. We added keyframe animations in variables, the styles in the corresponding SCSS file and the state variables to control them in InteractUI.tsx. This is a pattern we'll follow to add the remaining animations. For dramatic effect, I want the camera to rotate a little bit on game over. It should basically tell the user that the game is not 2D but actually 3D. The first thing would be to return a NewYork.tsx useFrame on game over. This will cause all platforms to stop moving. Go back to Bird.tsx where we'll define a constant for the camera rotations. This will be arranged for x and y, indicating the minimum and maximum values that the rotation can have. I also added a variable for the falling animation rotation limit, just to make the logic more explicit. Since we're gonna deal with the scene camera, get it from use3 and add a ref called camera target rotation. There'll be an object with x and y properties starting off as null. When the bird collides with something, this object will be created using a method called setUpCameraRotation, which will just set the ref with random numbers in the provided range. Just call set method when the bird collides, and check if the reference exists in useFrame. In case it does, set the camera's X and Y rotation to a LARP value between the current rotation and the target. LARP means linear interpolation, and it will give you a number closer to the final value in each frame, with steps as big as the third parameter you pass. So using 0.05 indicates we want a very smooth, relatively slow transition. Anything above 0.5 would feel like an instant, snap rotation. Take a look. Yeah, that doesn't look so good. And if the value is too low, it'll really take its time. So 0.05 is perfect. Let's recap. We added a return in NewYork.tsx to stop moving the platforms when game over is truthy, and a ref in Bird.tsx to store the camera rotation targets, which get assigned on collision and checked on useFrame, where we aim for a smooth camera rotation using Three's LARP built-in method. Let's create a big game over text that enters the screen for a moment and then disappears. That means more color variables and more keyframe animations for the translateX property. I'm also gonna add a little CSS reset over here so that the width and height properties also include the padding and border. Then go to InteractUI and import all of the classes we're gonna need, or rather name them here and create them in the styles later. We're gonna need 3 new state variables: game over text entering, exiting, and showing game over modal. Now we're gonna do the same thing we did with the game start useEffect, but for game over. This one does have 3 wait invocations though, and that's because we first have to wait half a second for the camera to rotate, then let the text animation enter, wait so people can see it, and finally make it exit. As the text exits, the game over modal also starts showing up. I'm leaving a couple placeholder functions here that we'll need later. And now a method to get the central area, which is where the game over text and modal will live. They're pretty simple, just divs containing divs really. Invoke it before getRayArea and go over to the InteractUI.tsx file to also add the central area styles, game over text, and all of that. Nothing crazy, just positioning it in the right place. As for the game over text, it'll have an absolute position in order to appear and disappear from the sides of the screen. Let's try it. Yeah, that looks pretty good. The game over modal shows right as the text is exiting, and the corners of this div that holds the score have a pixel art effect thanks to a very detailed clip path polygon. There are different websites and tools to make pixelated CSS corners this way. The text for the score numbers here and the game over text use basically the same text shadow as the game title. And don't forget to set a box shadow for the buttons and the skull container, for which it will be a barely noticeable dual inset shadow with different hues of beige. For the outside container, I'm using a filter with drop shadow since box shadow wouldn't work well due to the usage of clip path inside. Perfect! I'll show you all file changes as usual so you can see the exact styles I applied. The game's almost ready, but we still need to set up the score logic. Let's start by adding a new type called scoreReadySensor, an object containing the name of the sensor and a boolean to indicate if we have passed it or not. I'm going to expand the right area to start from grid column 2 instead of 3 so that the game title fits without wrapping. We also need styles for a floating score text in the central area, essentially the same as the numbers in the game over modal. Create a store variable to keep track of the score ready sensor and export it with a default value using an empty string for the name. Now bring it to Bird.tsx. Go to useFrame, and in the block where we check for sensor intersections, add another condition to the if statement to allow scoring only if we've passed the first core-ready sensor or if we're going to pass it in the current pair of pipes. Set it as passed inside and keep the rest as it was. I'll explain you in a second why this extra check is necessary. But for this to work, the sensor must have a name already. So let's assign it in NewYork.tsx. It'll be the sensor right after the last passed one, which we already get in the pipes plane offset useEffect. Extract the number to build the name and set the first core-ready sensor. Now we can go to InteractUI and finally import the score atom and the class we'll use in the score. I'm also renaming the getCentralArea method to getGameOverScreen because it's the only thing we'll be showing there. Alright, create the getScoreText method to return the floating score number. And also wire up the store variable in the GameOver model. Let's test it. Yeah, that's exactly what I wanted. So here's the thing with score-ready sensor. By the time the pipes get rearranged into their plain state, there will still be a sensor of an open pair of pipes that will pass through before getting to the first pair of pipes that actually have their plane offset. Look, you see? And that scores a fake point. This way we have total control over which pair of pipes can grant points, and that's too powerful. Recap, we added the new score-ready sensor type, added a store variable for it, set its value in NewYork.tsx using the last pass pipes we already gathered there. Added an extra check in Bird.tsx to only score points if we've passed the first core-ready sensor, or if we're about to pass it. And of course, we rendered the score on screen in InteractUI with its tiles. How about we make the restart game button actually work? We need to be able to tell when the game is being restarted. So let's include a store variable for that. First, we'll set it to true in InteractUI.tsx where we also hide the game over dialog with no exit animation whatsoever because we want to get back to the initial state where the bird and the pipes are idle as soon as possible. To actually restart the game, we'll need another useEffect in NewYork.tsx, one that runs when restarting game becomes true. We'll just set a Y target for all pipes consisting of the base top and bottom Y values we saved when setting up the first slice, and then set the pipe state to rearranging. Pretty simple. Let's see what that does so far. Nothing, while the game over screen disappears. We also forgot to reset the bird position, so move the initial position to a const outside the component. This will allow us to set it in both the restart and the initial useEffect. Bird.tsx will also react to the restarting of the game by resetting its position and rotation, playing the idle animation, resetting the camera's target rotation, the game over variable, and the score as well. Let me try again. Yeah, that works. But also not really. The pipes are going crazy when we start a new game. That's because we never set the restarting game variable to false. Let's do it in this last if statement within NewYork.tsx useFrame. Here we check if all pipes finish rearranging, and finally indicate that the restarting process is done. I'm not too satisfied with the entire logic because it's scattered in 3 files. You can probably centralize it a bit more. Let's try again though. Alright, perfect. We've closed the loop. Let's recap. In this commit, we created the restarting game's toe variable, wired up the restart button in InteractUI.tsx to actually do something. It sets the aforementioned variable to true and hides the game over modal. Added the restart game useEffect in NewYork.tsx, where pipes get reset to their base Y position, and we set their state to rearranging. And here in useFrame, we're detecting when pipes finish going back to their initial Y, so we set them to idle. Finally, in Bird.tsx, we reset the bird's animation, position, rotation, the camera's target rotation, the game over variable, and the score. You might have noticed that when we start a game, sometimes there's no space between the birds and the closing pipes, resulting in no time to get ready or unfair collisions. This is because the last pipe we passed before starting the game was the last one of its platform. Our game velocity will determine how often this can happen. The one I'm using at this point when playing is 5 multiplied by save delta. Let's say it again. Yeah, there you have it. It's time to use the second argument of addOffsets to platform, apply offsets map. This way we can offset only one pair of pipes within a platform and leave the rest up. This way we can offset only one pair of pipes within a platform and leave the rest up. In order to pass it a correct value, we need to check if the last passed pipes were also the last pair of their platform. I'll do that inside the platform slice's find index, while also checking for exact equality in the passed pipe's number instead of using includes, which can return incorrect values for numbers like 1 and 11. If the index of the found pipe is greater than 1, we'll set the passed last pipe variable to true, because in each platform the first pair has indexes 0, 1 and the second pair 2, 3. Use it in the addOffsets to platform invocation, and also for a first code-ready pipe. Let's see now. Yeah, that fixes it. Here's a quick log to check when the logic is triggered if you're curious. And the restart game useEffect doesn't need these dependencies. This time we only touched one file, but here's the recap anyway. Let's implement the bird skins. First of all, create a JSON file in the public directory containing the basic data of each one. I used a UUID generator site for the IDs, although it's probably not necessary, I just didn't want them to be the names. The unlocksAdd property determines the points needed to unlock it, and I also added a special one for the ghost bird, must get called consecutively, to create a custom rule where you have to get 13 twice in a row to unlock it. Feel free to get creative with the unlock conditions. We'll also need new store variables to check if we're currently selecting a bird, the bird we're previewing, and the current skin. And more animations for Translate X, of course. Before we implement IUI, let's just reinforce the wing flap method to prevent starting a game if we're selecting a bird. Here I also added new props for the button component, but ended up not using them, so feel free to skip that. Now import the new store variables in InteractUI and create a method that returns the bird selection interface. It'll have its own little methods for selecting and confirming birds, and going back to the main menu. It's very simple actually, just render as many buttons as bird skins there are, and a couple for confirm and back. Now hide the menu when selecting a bird and wire up the button that'll take us there. Feel free to adjust the zoom property of the camera, by the way. I don't think we'll need to look at the scene from that distance for the rest of the tutorial. Call the getBirdSelection method in the right area and let's see. Nice, the buttons lock the corresponding bird ID, it just needs some quick styling. First, we'll add a little animated arrow next to the buttons with the before pseudo element, and custom styles for a focus visible state. Remember that in order for the arrow to appear, the parent must have a set position other than static, so let's set it to relative. After that, use flex column in the list to make it all vertical. Nice. We still need to open the bird menu from the game over modal though, but let's review this commit first. Start by adding the bird skins JSON file, which defines the unlock rules. I also adjusted the zoom to fit the screen. I recommend you do it as well. It doesn't have to be the same number I used though. Added new store variables for the bird selection screen and applied them in Bird and InteractUI to display the skin list. The new HTML is still very simple and reuses the button component. Lastly, we added flex column styles and made the last couple of buttons smaller so they stand out. In order to actually unlock the birds, we need to keep track of that in local storage. If you were to expand the app with an external database and make users register, then you'd store it there. But we're going with local storage for simplicity's sake. So I'll create a local storage.ts file in a db folder and include some functions to get and set the variables we need. That is, highest score, unlocked skins, and the last selected skin. We'll go over the functions in a moment, but let's apply them first. In InteractUI, make sure to disable the button to confirm a bird if the skin is not unlocked. Also, add styles for the disabled state of the button as well. I'll reduce the brightness and set the cursor to not allowed. About the local storage functions, they follow a basic pattern of retrieving the desired values and returning a default one if it doesn't exist or if it's invalid. And the ones that set values perform minimal logic before doing so. Recap's gonna be really easy this time. We created the local storage file and used it to disable the OK button if the selected skin is not unlocked. Let's actually set up the bird skin preview. Start by importing the bird skins JSON in Bird.tsx and creating an object to hold the location of each skin's picture relative to the public folder. Also, bring in the preview in BirdAtom and the useTexture hook from Dray to load the texture images that we'll set in the bird material, and pass the object we just made. I'll show you in detail in just a second. Before we go over that, write the setTexture method where we just pick the requested skin from the texture subject resulting from the useTexture hook. After you have the texture, get the bird body and apply it to its material. Remember that our scene child is the bird rig, so the skeleton that holds the animations for the body. In this method, we also set some texture properties. One of the most interesting is min filter, which affects how the texture looks when it's drawn smaller than its original resolution. Like when the textured object is far away, texture colors might look blurry. The different values of min filter control how the texture image data is sampled or averaged, or in other words, if it should look blurrier or sharper. In our case, setTexture uses nearest filter to keep our low resolution textures looking sharp. Now we can see all skins. Great. Let's make sure we can select them. Go to InteractUI and wire up the bird selection methods to set the previewing skin as the current one if it's unlocked. Also, I'll make another method to get a little hint message every time we preview a skin that's not unlocked. It'll have styles resembling the start game message. Now if we just click on any skin, the bird's material would get its texture as a preview, and the unlock hint shows down there. Alright, quick recap. We implemented the ability to set textures with the useTexture hook, which is just an abstraction of Tree's texture loader. I also deleted our testing useEffect that locked the pipe state from NewYork.tsx. We also set the preview bird and the current scheme from the bird selection menu in InteractUI and added an unlock hint message. Now we have to implement the unlock skin logic. So far, we don't really call any functions when the required conditions are met. So let's do that now. Create a store variable to keep track of the last cores, a number array, and another one to indicate that we have just unlocked a skin. This one will be a string containing the skin ID. Bring them to Bird.tsx and define a constant for the number of scores we want to keep. I'm going for 2, which is what our unlock logic requires, since the ghost bird checks for 2 particular scores in a row. We'll need a method that receives the last calls and loops through all skins, checking which one we've unlocked. This one will be called on game over, of course, and don't forget to save the highest score in local storage. And as you can see, we're using the constant defined a couple minutes ago to prevent the array from growing larger than necessary. Notice there's 2 if statements, one for the skins without a consecutive score requirement, and one for the ones with it, so just the ghost bird. As for InteractUI, we need to show a message telling the user that they unlocked a new skin. But also, it is here that I check for the last selected skin from local storage and assign it. Yeah, that should probably be in Bird.tsx. Of course, when checking for the last selected skin, we verify that it's been correctly unlocked first. If a value exists as the current skin but it's not unlocked, it means it's been tampered with, and so we just lock all skins again. Let me reset the value of just unlocked skin in restart game and also save the last selected skin when confirming it so our decision stays in local storage. By the way, this method select bird should definitely be called preview bird. Next up, we'll add the bird unlock message in the same style of the start game message. Just some text down there telling you, hey, congrats, you've unlocked a bird. And you can wire up the highest core value from local storage in the game over dialog now. Styles will be shared with start message, in fact. Let's try to unlock the Dragonheart bird. We just need to get 25 points. There you have it. The message looks a bit too high because I have the dev console open from the bottom, but otherwise it should be fine. We can use the Dragonheart's king now, and if we reload the page, it will still be there as the currently selected bird. Recap time. We started saving the last course in Bird.tsx so that we can pass it to a method to check for unlocked skins. The current skin is set in a useEffect in InteractUI, and every time a bird is confirmed, we save the last selected skin in local storage. We also included a bird unlocked message and store variables to support our skin unlocking shenanigans. I reused some styles for the unlocked bird message. Look at what happens if we just press and hold the spacebar. The bird flies into infinity and can collide with pipes up there. You can prevent this by returning right before applying the jump velocity if its Y position is larger than a certain threshold. Very simple. Let's see now. Yeah, it stops right there. Very well. Create a restart game and select bird function that acts as a shortcut to restart the game and immediately go to the bird selection menu. Let's see. And it works perfectly. Nice smooth transition into the bird selection. Not a lot to see in this recap. I'm just happy to announce that the hard part's over and we're almost done. For the cherry and the sprinkle on top, let's add a background texture and animate the buildings and clouds in the back. But first, you might have noticed this error in the console saying the assets in the public directory cannot be imported from JavaScript. Even if it works, that warning is annoying, so let's move the file into the src directory. Just move birdskings.json into the database folder in src and update all imports. There's only 4 files that are imported, so it shouldn't take long. About the background, I made this image in Photoshop resembling a sky with stars in it by using a gradient and a brush that had these particles or a splatter effect. I encourage you to make yours, but this file is also available in the Bird.tsx repo. Move it to the public folder and pass it as an argument to the useLoader hook in NewYork.tsx. We could also load it with useTexture, but since we need to load only one image, it's perfectly fine to do it this way. And so we'll learn about a new hook from React Refactor. Now go to the first useEffect and set scene.background to the texture we just loaded. The difference might be subtle at first, but if you comment out the code, you'll see how the gradient and stars do make an impact. Note that for the texture's color to be accurate, you need to set its color space property to 3.srgb color space. And don't forget to add the background texture to the useEffect's dependencies. Before we animate the background models, save the base Y of each object and make a face property, which will be a random number between 0 and pi multiplied by 2, so 6.2. It will serve as a random angle for each individual object. About that, the user data property is a blank Three.js object that we can use to store our own properties. We'll need bush offset and loop trigger constants. Add them and they'll make sense when we use them in a moment. I'll also take this chance to export a mobile width variable from the store to allow for small animation adjustments when the viewport is smaller than that. To check for the current size of the canvas, get the size variable from useTree. Every time the viewport is resized, its value will change as well. And get the clock utility variable from it too. We'll use it to get the elapsed time since the scene was loaded, a useful number for animations. Now I'm gonna create a method called updateBackground that's gonna be really long and will be invoked as the last thing we do in useFrame. We'll go over the specifics of it during the recap. For now, let's duplicate the bush in the first useEffect because we're gonna have 2 of them, so that we can loop the bushes without leaving a big gap in between. Set the X position of the copy at the very end of the first bush plus the offset we defined. Now if we go to update background and set the bush velocity to something like 20, we'll be able to see it in action real quick. See, that's where the second bush starts, and they loop perfectly. You can increase the gap by tweaking the brush offset constant. So let's recap before we review the background animation logic. We added the background texture PNG file, moved the bird skins from the public directory into the source one, and updated the imports in all other files that used it. Defined the mobile width constant in the store and exported it. And in NewYork.tsx, we applied the background texture and created the updateBackground method, which executes at the end of useFrame. So what's the deal with updateBackground? The function starts by getting all objects that we aim to animate, finding them in the scene's children. Then we define their velocity. We essentially just make them move along the x-axis and reposition them at the end when they reach a certain threshold, which I call the looping position. This pattern is repeated for all objects. The mobile width will be used to adjust the restart and looping position. After that, I loop through all generic buildings and update their X position, and the same for all groups of objects like the clouds. The clouds of the special buildings can have custom speeds and stuff like that. For the cloud's Y position, I'm using mat.coast to get a smooth, bouncing animation, since it always returns a number between -1 and 1. So we just have to adjust it a little bit by adding the base Y of the object and multiplying it by another number. Mat.cosine is used for this kind of swinging animation very often. I employ this pattern for all objects, except for the cloud disks. Those don't move and only get their Y rotation value updated. Take your time to play with every object and the way it's animated. Turns out we need a stop variable to know when the game has loaded, and I consider that's true right after the scene children of NewYork.tsx are set. We cannot execute the useFrame logic if the game hasn't loaded, because that will create a small gap between the first platform and the other 6. It's especially noticeable if you set the game velocity to something like 30. Let me show you the gap I was talking about. There you have it. I'll also adjust all game variables to be production ready. Let's see. Yeah, that's so snappy. Again, take your time to test each one and stick with what feels good to you. And don't forget to try it on your phone. Very easy recap. This time we only added the game loaded atom that becomes true after loading all platforms, and then we adjusted the game variables. I forgot to disable the deb helpers. This feels like the grand inauguration of a building or something, but the game does look much more beautiful without the bounding box helpers. So let's enjoy some of that. Set the show helpers constant to false in the store and notice how the little UI panel disappears too. You can turn it back on anytime you need to work on something and enjoy all of its glorious sliders. This angle looks pretty funky, doesn't it? We have to check that the app actually compiles, so execute npm run build. Oh, it's complaining about that one type error in the directional light helper in NewYork.tsx. The problem here is that useHelper does not want the type of the ref to include null in any case, but we need to use it as the initial value that gets immediately updated after the ref is attached to the light. So let's cast it as the same type but without null, and that fixes it. You can quickly test that the directional light helper still works in the little UI panel. Now we're ready to build again. Perfect, no errors this time. At this point you could ship the game to any hosting provider. It truly feels like the ending of a major chapter, cause it's the last episode. We fixed that typing error in NewYork.tsx and I also added some minor, miscellaneous changes. Alright everyone, thanks for watching and I hope you took something of value away from this video. The fun doesn't have to end here though. Subscribe if you enjoyed it and come say hi on LinkedIn, links in the description below. Leave a comment, let me know your thoughts on the game. What would you have changed? What different game modes could be spawned? Or just about anything, really. Very well. Take care and see you next time.